Well, before we get going into Section 2, I'd like to congratulate everyone that's at this point for doing the work necessary to get through Section 1. So far, appreciate everyone's effort and the change of scenery around class. I think it's working out great. Section 2 deals with, and all we're going to do is focus in on the addition and subtraction formulas for sine and cosine, and also the ones for tangent. And so essentially what these are formulas that give us the ability to find exact values for some angles. There's certainly not going to be every possible angle out there, but for some angles based off of the values on our unit circle. Those are ones that we know exactly right now. Everything else we would have to rely on our calculator to find the approximate sine and cosine and tangent. Actually, all 6 trig values. You should find these on all of these formulas are on your unit circle sheet. There is no expectation for you to memorize these. But I did, in the paragraph here, kind of outline how you can keep the sine and cosine addition subtraction formula straight. If you look at the first two here, there's certainly a pattern that develops. These are for the addition subtraction of the sine, and what you see is the first term is a multiplication of sine cosine, second term is cosine sine, and the sign linking them corresponds to the sign inside the addition or subtraction rule. And so sine cosine, cosine sine, sine matches up. Whereas in the next two, the cosine addition subtractions, we also have a pattern, but the pattern is cosine cosine, sine sine. And the sign linking each term is opposite of what's inside the parentheses here. I don't know that there's any special way to help you memorize the tangent rule, not that you have to. So what we're going to be doing are problems like this next slide. So it says find an exact value for the cosine of 75 degrees. Well, we have the ability to find exact values for angles like 30, 60, 45, 90, all the angles on our unit circle. And with the addition subtraction formulas, we can now take something like 75 degrees and write it in terms of an addition. And so one of the important things that we have to be able to do is not look at what this number right here is, but how could I write that so that I can use my addition subtraction formulas. And the obvious one here is 75 equals 30 plus 45. And these two values right here need to be values from our unit circle. And so we go in and use our cosine rule. And the cosine rule, so I'm going to start the problem right here with what was given to me. And then I'm going to, just like all of my other formulas, I'm going to start with the formula. And so the rule for cosine was, it's cosine, cosine, sine, sine. And then the sign in between here is opposite the operation. So we added 30 and 45, so we're going to have a subtraction here. And now we just fill in the angles. 30, 45, 30, 45. And at this point, now we just use our unit circle values. Cosine of 30 degrees is square root of 3 over 2 times the cosine of 45 is square root of 2 over 2 minus the sine of 30 degrees is 1/2 times the sine of 45 square root of 2 over 2. And now we just perform the arithmetic. Square root of 6 over 4 minus square root of 2 over 4. And I guess you could leave your answer like that, but might as well combine it into a single fraction since we already have a common denominator of 4. And my numerator is just going to be square root of 6 minus square root of 2. That is not simplifiable into the square root of 4. That's as far as I can go right there. And so there's the exact value for the cosine of 75 degrees. In this next example, let's look at using radians. Pi over 12 is, and we still want to probably think of it in terms of degrees because that's what we're most comfortable in. Quick little mental conversion, pi over 12 is 15 degrees, which we could go with and break that down into a subtraction, 45 minus 30. But we also have the option of using 60 minus 45. Either of those will generate the correct solution. In fact, I'm going to challenge you to prove that to me. But for the sake of the example here, let's use 45 minus 30 degrees. And so the sine of pi over 12, start with your given. Oops, what is that? Eraser, there we go. Pi over 12 equals, then we want to show, which I didn't do last problem, but it should be there. You got to show what you're breaking it down to. Now, since we're starting in radians, we need to have radians here. So 45 degrees was what we were going to go with first, which is pi over 4, minus 30 degrees, which is pi over 6. And so we're doing a subtraction of a sine, and so we follow the sine pattern, which goes sine, cosine, cosine, sine. The sine here matches the sine inside, and you fill in your angles, keep it in the same order, pi over 4, pi over 6, pi over 4, oops, pi over 6. Gotta lift my finger up, I think. Sorry about that last step, a little illegible, but I think you should, if you take a pause, you should be able to figure those out. The sine of pi over 4, square root of 2 over 2. Cosine of pi over 6 is, let's see, cosine of pi over 6, that's the x-coordinate, which is square root of 3 over 2, minus square root of 2 over 2 times 1/2. And so when we break this down, we have our common denominator of 4, and our numerator will be square root of 6 minus square root of 2. So, great application of finding exact answers of angles other than some of the ones on our unit circle. We certainly have to fall back and rely on the ones on the unit circle though. What do we have here? Find the exact value of the expression sine 20 cosine 40 degrees plus cosine 20 sine 40 degrees. So in other words, they're showing us, they're starting off with the actual right side of the identity and asking us to go up to backtrack, because we certainly don't have exact values for 20 degrees and 40 degrees. But I do know that 20 and 40 is 60 degrees, and so let's go and see which rule this is right here. So go sine, cosine, cosine, sine. So right off the bat, I know that I'm dealing with one of the sine rules. And so since it's an addition between the two terms, I know that it's an addition here. And it's an addition of the angles used, 20 and 40, which equals the sine of 60 degrees, which is the square root of 3 over 2. Questions like this, I don't know that the real world application of them is evident. I think they're more there for you to get more comfortable with the actual addition subtraction rules. Like I said, I don't make you memorize those addition subtraction rules because it's something that if we have a need for them, we have the ability to look them up. I don't think any standardized test has any expectation of memorizing these also. So the last thing I want to do is take a look at an identity here. And we haven't used a tangent addition rule, so we might as well use an identity or verify an identity using a tangent addition. So obviously, as you look at this, I'm already starting to show that I'm going to be working with the right side, because I have the tangent of pi over 4 plus x. In terms of these verifying identities, it's a pretty consistent problem right on through the whole chapter. So we certainly had our practice in section 1, but it's a skill that we need to keep working on. And so I see an addition of tangent, so I go into grab my unit circle, find that particular rule, and it's a fraction. So the top of it says the tangent of the first term inside, so it's the tangent of pi over 4 plus, okay, so I have a plus there that matches that, the tangent of the second term. Now, there's my numerator. Now I go down to the denominator, 1 minus the tangent of the first term, so tangent of pi over 4, times the tangent of the second term, tangent of x. Now, at this point, I have some trig that I can evaluate. Pi over 4 is on our unit circle. It's the 45-degree one. Tangent, opposite over adjacent, sine over cosine, square root of 2 over 2 over square root of 2 over 2 is 1. Plus the tangent of x. So already I'm starting to look like my left side of the equation. 1 minus tangent of pi over 4 is 1. We just did that in the numerator. 1 times tangent of x is tangent of x. Left hand side equals right hand side, and so I just verified my identity. So good luck as you go into the homework and apply the addition and subtraction rules for sine, cosine, and tangent. Make sure you keep asking questions and make sure you stay on top of your work. Good luck.